Okay, now it's time to look at servos. And servos come in different sizes. This little tiny one, for example, is called a 2-gram servo. These are 9-gram servos, and this is a 55-gram servo. Now, in this curriculum that I'm working on, we will be using one of these larger servos per student. We'll be using up to 8 of these medium size, and we're not going to be using any of these smaller servos. Now, these servos come in 2 types. The first type, you tell it what angle you want it to travel to. The second type, you tell it what speed you want it to spin at. So basically what I'm saying is some of these go to a position and stop, whereas others, they just spin freely. They just keep going and going and going. And you can see this one is an FS. Let me see if you can see that. This one is an FS90R, continuous servo. And these two, one of these is labeled MG90S, and the other is labeled, is also labeled MG90S. Now these are very different. Now, well, they're a little bit different. I guess they're not very different. They're a little bit different. There is no servo standard. Now, most companies that make these servos, and they make them, cheaply, or as we say, reasonably priced, they use the Tower Pro standard sort of thing, but they'll change some things sometimes. And so it's kind of hit and miss as to what the size will actually be, but they all kind of sort of look like Tower Pro. Now, the Tower Pro itself has a very strict standard. And for example, this is what a Tower Pro MG90S is supposed to look like. And the thing you're going to want to notice is what I'm calling the shoulder, right? The distance between the top of the box to the flange where it hooks in. See how that's kind of just a short distance? If you look at this other one, even though it's labeled the same thing, look at the difference. It's a much longer, it's got a much bigger shoulders is what I want to say. As you can see right there. So when you look at Tower Pro, this one with the big shoulders is actually based on the MG90, which is a nylon geared servo. This is based on the MG90S, which is a steel gear. See, these gears inside here are made out of steel instead of nylon. And I usually get these because I think they're going to last longer. I hope they're going to last longer. We'll see. But you can see there are basically 2 different standards. Now, if we look at the standard for these MG90S, it says that the thickness is 12.4. So let's measure. This one is 12 point, ooh, can you see that? 12.13. It's not, doesn't really conform with the standard at all. Now let's look at this one. 12.24. So we're not really seeing the real standard here. Let me check that D. 12 point. Oh wait, 12 point. Yeah, 12.4 is what D is supposed to be. And then here we're getting 12.21. Oh, well, if we go to the bottom, no, it's kind of hit and miss there. But it's definitely not 12.4, which would be the Tower Pro. That one is less. So this one, which has no brand name on it, and this one, which does, it has a brand name on it. This one is closer to the Tower Pro in terms of size. It also looks more like a Tower Pro MG90S because of the smaller shoulders. This one looks a lot like the MG90, Tower Pro MG90, because of the larger shoulders here, but it's still not to spec. It's a little bit slimmer than it should be. Let's look at it in a different direction. So 22.8 this way. 23 is what we get. So that's reasonably close, I guess. This one, however, look at that. That's right on, 22.8. So conforming to the standard is kind of hit and miss with these cheap servos. And what you're going to want to do when you are when you have these when you have your templates printed out, you're probably going to want to measure the servo you got against the hole that I've provided you to cut out. If it's close, you're okay. You'll probably be okay. If it's off by a lot, you might want to take like a red pen or a red pencil and redraw it so that you center this where I've shown you it should be, and then redraw it and cut it that way, right? And these lines are showing you it should go like this. So that's what you're going to want to do when you have your servos chosen. If they're very similar to ones I have, then they'll fit perfectly. If they're off by a little bit, it's cardboard. You can squeeze them through okay. Now let's talk a little bit more about these. Now, 3 wires. These servos have 3 wires: a ground wire, a power wire, and a servo position wire. And I think I'll probably put this in another video talking about the servo position. But the voltage matters. Now, some servos you can get, and they are rated for 3.3 volts. And your microbit has a 3.3 volt output. So you would be able to connect that servo to the 3 volt pin coming out of the microbit, and you'd actually be able to run it. But most servos run at 4.8 volts or higher. The vast majority of servos out there run at the higher voltage. So don't be tricked into using too low a voltage. Now this one in particular, if you use too low a voltage, it'll actually spin around and around and around without stopping. It's not the wrong type of servo, it's just too low a voltage going into it. This one has to have a good 5 volts to operate. Same with this one. So we're going to be running our servos on 5 volts, which is what a board like this, an extension board like this, provides 5 volts to the servos. It uses VN, so whatever voltage is coming in, and this allows you to go 3.5 to 5.5. But if we are powering it with a battery pack like this, which holds surprise, surprise, for batteries, these are AAAs, they're small. For AAA batteries, I'm using AAAs to keep the weight down. If you're using 4 batteries like this, these are rechargeable, so the output voltage is about 5 volts. Now, if you're using a different type, these are lithium ion batteries, rechargeable lithium ion. And these, internally, they use a 3.7 voltage battery, but externally, that voltage is regulated to 1.5 volts. So 4 of these will give us 6 volts of power. Now, this board will take 6 volts, even though it only says 5.5. The chips in here, I've looked them up, they will take a lot more power. They'll go up to 20 volts. I would not push it like that. I've already burned out one of my extension boards. I don't want to burn out another one. So we'll be powering this at around 5 volts because like I said, I'm using those rechargeable batteries that do not have the full 1.5 volts each. Okay. Now this also has power input, and we're going to be powering this with 5 volts as well. This takes whatever voltage comes in, applies it to the servo. So basically, these two extension boards allow us to run our servos at the full 5 volts. That's going to make these run well. And when we're doing the robotic dog, our servos are going to be under a lot of stress. So we want them to have the full 5 volts, not the 3.3. Okay. So we're going to be using a lot of these. 9 gram, 180. They go from 0 to 180. We'll be using a lot of these servos. They come in bags like this usually. See if I can get this open. Oh, look at that, I did. And they come with the servo, and they come with these extra parts. And these are called servo horns. Now, when you get one of these, you need to keep these with it. And I'll tell you why. Now, if you have standardized on your servos, you've gotten them all from the same place, that's good. These are interchangeable. But if you've done something crazy like I have, where you've got more than one type of servo in your fleet, what you're going to find is that these gears at the top are not the same size. One's a little bit bigger than the other. And sometimes that's because they have different numbers of teeth as well. The standard is 21 teeth around this. So if you've mixed up your servo horns and you don't know which is which, you may or may not have a match. This one's too big. Oh no. This one is too small. Oh no. So you're going to have to keep them separate if you have more than one servo type, because they're not guaranteed to all be the same. Not guaranteed. So, and if you're doing this curriculum with a class of 10 to 30 students, you're going to have a couple hundred of these servos in stock. A couple hundred, 300, something like that. And with 300, you're going to have a failure rate of 1% or so, which means that every year you need to replace 3, right? And if you don't get the exact same servo, you can have one of those problems where either it's a very different sort of fit because of the way the because remember the shoulders are different, or the servo horns don't fit. And if somebody has, pushed the wrong servo iron onto the wrong servo and screwed it in tight, well, it's going to be messy. So you're going to want to stick with a name brand. You're not going to want to do generics. This one does not have a name. This one does. This one has a name brand. And so far, the ones like this with the name brand, this is Musei. Anyways, having a name brand means that I can get the same servo over and over again. Okay. So how do these, we'll talk about how the servos work. I need to set up some electronics to show that. So in our curriculum, we will be using one of these for the animatronic robots we're going to make, and we'll need up to 8 of these to do the robotic dog. What else do we need? For the maze runner, the robot that runs through a maze, we're going to use these for line following. These are infrared sensors, and they come with the pins bent, and I just straighten them out so that I can install them into our cardboard robot. Each student is going to have 2 of these, so that these have an analog output, and we'll be using the analog output to do PID control for line following. Another component that we're going to be using is this one. And this is a distance sensor. And unfortunately, these distance sensors come out of the bag. I said come out of the bag. Let's try that again. They come out of the bag like this, where the pins need to be soldered on. And they do that to give you some amount of flexibility. So you'll need to have a soldering iron, and you'll put these into the pins, and then you'll solder them across the top, so that you end up with a component like this, where the sensor is on one side and the pins are on the other, and we can tape these onto our cardboard robots and use them as rangefinders. Now, while the servos connect up to the servo pins, these connect up to the I²C. We talked a little bit about I²C before. And we're going to use, for the Maze Explorer, the cart that runs the maze, we need 3 sensors. We're going to have one front, left, and right to find out where the walls are. Each time it comes to a new spot, it's going to check those 3 sensors for walls. So we're going to need 3 ways to connect to the I²C. This one has 2, and this one has none unless you add pins. Like I have. I've talked about that before. I've soldered these pins on, so I have access to all the various pins and I²C. So what we're going to have to do is use one of 2 things. We can use a little tiny breadboard like this, and we'll take a single I²C connection, put the pins in, and then we can put connections in to our 3 sensors, so that they're all on the I²C bus, which is a serial bus. So one out. So now we saw some boards that have like 3 of these. That'd be great. Except that most of the time, when you see 3 of these, they don't have servos, or they don't have something that we need. Okay, so we can use this little breadboard like these, and these are very cheap, or we can get a little board like this, which is essentially a breadboard, except it's all connected already. And it has input, and then it has a whole bunch of outputs. These might be easier for the kids to use. They're a little more expensive, but you can see they're well labeled and stuff. These you're working without labels. You're having to put the pins in. If you get them reversed, then it doesn't work. Okay, so I think we've covered the different hardware. So 2 of these, one of either these, or maybe both, one of each. I'm going to be using one of each. 3 of these for each student. These are the distance sensors. One of either of these, one of these, and 8 of these, unless you let the kids keep their stuff put together. I ran the animatronics project last school year, and the kids really wanted to keep their robots intact, but we couldn't let them do that because we needed the servos for the next year. So I don't know if having them take their robots apart to reuse parts is going to be something that's like painful for them to do or not. We'll have to wait and see, but maybe you need 4 of the distance sensors because we use 1 in the first project and 3 in the second project, so that they can keep them together, their robots together, and then when they leave at the end of the year, you can go in there and cut them to pieces and take all the parts out. to put it bluntly, that's what I had to do. So these are the components you need. Oh, almost forgot, you're going to need DuPont wires, and usually you can buy a set of DuPont wires that come with different connections. They have this one that has 2 female connections, so that you can plug them into pins on one board and plug them into here. For example, if you are using something like this, you're going to need some male and some female, so that you can plug the female side into the pins, have the male side plug in, and then male side again to go out, and then plug into with a female side to plug into the sensors. So depending on that, this you need with a board like this, which is the I2C expansion board. You just need the female to female. Those are fine. Okay, is that everything covered? Yes, I think so. All right, next we need to talk about calibrating these extension boards, right? We've got this little sticker on them that tells you how to calibrate them. Well, we're going to need to talk about that and how to get that done, because they do need to be calibrated. You can run servos as is, you can run this as is. They will not be completely accurate. And we'll talk about why that is and how to calibrate. Okay, thanks for watching.